Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the energy equation for fuel cell. We have talked about the reversible chemical reactions. Some reactions can be made to approach reversibility by having them taking place in an electrolytic cell, as is shown in the figure. When a potential exactly equal to the electromotive force of the cell is applied, no reaction takes place. When the applied potential is increased slightly, the reaction proceeds in one direction, and if the applied potential is decreased slightly, the reaction proceeds in the opposite direction. The work done is the electrical energy supplied or delivered. The fuel cell contains an ion exchange membrane that separates an electrolyte from the reactant and product gases. In the basic fuel cell, hydrogen and oxygen gases are supplied separately, so the hydrogen gas enters into the anode, where it dissociates into atomic hydrogen and further into hydrogen ion and electrons. The hydrogen ions travel through the membranes or electrolyte, and the electrons through the external circuit, and they combine again with oxygen at the cathode to produce water. There is an electrical potential difference between the anode and cathode, and the flow of electrons constitutes a current, which is how the electrical work is delivered to the external load. Taking proton exchange membranes fuel cell as example. The fuel cell operates with hydrogen as the fuel and oxygen as the oxidizer. The reactions at these electrodes and the overall cell reaction are labeled on the figure. The only products of this fuel cell are water, power generated, and waste heat. For PEMFCs, charge-carrying hydrogen ions are conducted through the electrolytic membranes. For acceptable ion conductivity, high membrane water content is required. This requirement restricts the fuel cell to operating below the boiling point of water, so PEMFCs typically operate at temperatures in the range 60 to 80 degrees centigrade. Cooling is generally needed to maintain the fuel cell at the operating temperature. Owing to the relatively low temperature operation of proton exchange membrane fuel cells, hydrogen delivered from hydrocarbon feedstock must be produced using external reforming, while costly platinum catalysts are required at both the anode and cathode to increase ionization reaction rates. When acid electrolyte is used, the chemical reaction in hydrogen fuel cell is as follows. There is reaction happened in the oxide electrode. Complete fuel cell energy balance can be expressed as where the work output by the fuel cell when one hydrogen molecule is involved in the reaction is the heat release is the work done to the system by environmental pressure resulting from the reduction of the volume of water vapor when vapor condenses into water. For the above-mentioned hydrogen-oxygen fuel cell, the general formula of the electrical power output per mole of hydrogen is. The meanings and values of parameters in this equation are. Okay, that's all for this task. Thank you very much, and see you next time.